at the node level where you pick it up, or perhaps when you draw it back, when you get this data, look for some sort of trends in it. And the longer the trend that you look at, perhaps the better it might be to deciding what's a lengthier trend, or what's sort of happening over a long sort of period. Like for example there, that weekend when somebody came to visit, you wouldn't necessarily have noticed that looking on the day-by-day thing. It's only when you look at things in a more sort of global perspective. And similarly, the other one that I was looking at, that is a sort of daily one for it. But again, you can sort of look at it by week or by month. What's happening over the month? So again, you can perhaps sort of start to look for trends in that data. So at that point, you're into sort of taking that data and performing some statistical analysis on it, or perhaps some data mining techniques. You might have a bit of sort of AI thrown in there to spot relationships between multiple sensors and the like. So that's really sort of, as I say, just what we're looking at in some ways in the lab. So you could build one of those almost right now. You could build a conceptual one out of those sort of fidget kits. It's just a matter of getting the right sensors, and you can perhaps sort of piece something together. And in fact, just as a last quick demo, I had one of my students last year create a sensor kit that they carried about with them. And I've uploaded this to Moodle again to sort of have a look at. The project that I was dealing with 2 years ago, sorry, it was. The guy was a keen cyclist, and he wanted to grab sensor data as he was cycling about the city to it, and then record that and be able to pass that on live to other cyclists, rather like Google Maps does with traffic. The Google Maps sort of takes everybody who's connected to Google Maps or their location and can place people where they are in their car and how fast they're moving, and decide whether or not there's a traffic jam on your route, and hence advise you to go to another route. So we got hold of some specialised sensors, air quality, noise, sort of temperature ones, built it together into a sort of carry-about device. His citizen sensor device, if you like, put it onto a Raspberry Pi. It ended up being quite a clunky thing, if you like. It's not like that nice little white box that you've got. But then started broadcasting out. These sensors will be streaming data out to a local machine, which will then publish that to the outside world. Now, so far in the labs, what we've been doing is picking up that sensor data and writing it into a database. And last week you saw you could sort of grab that out of the database as needed. Now, the method that we've used so far meant that you had to be write proactive programs that went to the database and asked for that data. There's another one that we'll be looking at next week called MQTT, which is what's called a message broker that just broadcasts it out, and anybody who registers an interest in that sensor automatically gets the data. So if within the software you can say, look, I'm interested in this cloud service that's broadcasting out data from the Oxford Road area, you could pick up those sorts of things. So we set up an MQTT broker that broadcasts out temperature, air, noise levels, together with other sort of data about location and time, whatever. And in his mobile device, that will then sort of send it out. So how it was connected, it's not perhaps a blockish diagram as before. That particular device couldn't broadcast out. It was just controlling the sensors. So that had to connect to the phone, and the phone did the broadcasting. So the phone was the gateway, and that was the node with the sensors attached. So it's just really a sort of practical implementation of where these sort of things are coming from. And then at the other side, a particular mobile device could act as a receiver and say, okay, well, I'm interested in anything that's broadcasting out that particular MQTT data. And so you could pick up on, or you say, oh, I'm interested in Manchester environmental data for the roads. And as it's coming through, it could come through on the phone and give you sort of live updates. Now, it's not particularly useful if it's on your phone and you're cycling, so you can't see it like that. So what you can also do is perhaps sort of send it to something like a Fitbit or a watch that you're wearing and get it vibrating different patterns of behaviour as to how you could go on. That's down to how your interface works. Rather like some of those other more novel ideas that I told you about, getting away from the idea of using screens, you sort of can build something into your, sort of like a device that you could put onto the bike itself to decide where to go. Not necessarily a screen, just some sort of more ambient thing, whether it's a light. I mentioned this idea perhaps of having an umbrella, where in the handle you keep it next to your front door, and as you're walking out, the handle's either glowing red or green according to whether it's going to rain or not, and that just tells you whether to pick it up. So you don't have to have a screen all the time as that interface with your devices, which is what we're a bit sort of obsessed with. Is that we're obsessed with seeing screens all the time, whether it's on our phone or laptop or TV or whatever. We need to sort of incorporate these more into your sort of everyday environment to it. Now, a lot of these ideas are just going to come out in what talking about today and start of next week as well. Last week I was talking about the sort of network part to it, and I finished off before talking about the operating system, which I want to sort of briefly mention before going on to this wider data analysis part. One of the key things about the network performance is this concept of limited power supply. That wherever you're sort of passing these messages through, the power consumption of communications is relatively high. It's typically the biggest power consumer in that little node device is its communication part to it. And depending on how you set your network up, and we mentioned lots of things last week about you're not necessarily just in isolation broadcasting out your data, you may be part of a network and passing on messages, and you're having to listen to other people and relay on messages and acting as both a client and server rather than just a passive client sending the data out for it. And this leads to problems in sense networks about where failure of networks where you can't get through a certain path and all that sort of thing. They were the sorts of things that we looked at last week and why power consumption tends to be one of the sort of major problems of it, about perhaps where you place nodes. You can have a sort of whole series of nodes around and who they can communicate with. You might end up with some particular nodes being more important than others. There, because if that's your gateway node to the sort of internet, this is receiving everybody's traffic, and so it has to work harder maybe than the other ones, but perhaps sort of harder than one of these on the outskirts. So that's doing a lot of forwarding. As this node wants to send data out, it has to sort of send it through a particular route, and that node's receiving everybody's. So it's doing more work for other people than perhaps it is for itself, and using more power up as a sort of consequence to it. So a solution there might be to add more next to the gateway. You might need to think about your actual topology of that sort of network, where you lay it out. And it might just fail, just as I say, because of a battery sort of going more quickly than sort of others. So it might matter whereabouts you put your gateway. You'll have seen that to a small extent, perhaps, inside your own house where you put the router. Where do you put your router and any sort of repeaters? It does matter that you put your router in as accessible a position for the rest of the house as possible, so that everybody can sort of pick up their signals. Because unfortunately inside a house situation, an individual PC or phone that's connecting to your router isn't acting as a router in itself. It's not helping the others out. Inside a sort of router with a Wi-Fi, they're all just directly connecting to that sort of gateway. So that would have to be much more central. If this one couldn't communicate with it, if this was Wi-Fi connection, and that couldn't actually reach it, then that couldn't get a connection to the outside world. And so you'd have to rely on going through others. Well, that's not really how most people's Wi-Fi devices work. But your phone sort of doesn't act as that relay. But we need to build that sort of thing into our network operating system for a node, or into the operating system in general, and where to put it. So this idea about it being possibly too far away may result in sort of delay to sort of get stuff through. So I've had a brief look there really at the sort of networking problem to it, and in connecting through all these different things, yeah, one thing to think of is what wireless networking you're using, and we'll look at other ones like Bluetooth and Zigbee later. But when they are communicating, what sort of agreed protocol is it? I mean, you could say just